Welcome to this week's Training Tuesday, everyone. It's great to have you with us today. I am Heidi Reese here at Dayton Superior, and I am the Training Programs Manager, works along Chuck Hope. We all know Chuck. Just a couple of items to go over before we get to today's training. So everyone on the call is muted, but don't let that stop you from asking any questions. We'll have a mini question answer session at the end. Also, all of these are being recorded so that you can go and listen to them at a later date, or if you know someone who needs to see it, or you feel like they need to, they're all out on our YouTube channel for Dayton Superior, and they're also on DaytonSuperior.com. Just search for Training Tuesday, and you'll see two links. One will have all of the, well, this one as well as the past recordings, and then you'll see the link to sign up as well. All right. So this training is intended for training purposes only. So what we're presenting, anything that's in the document that we're going to present, as far as technical or safety specifications, please go to DaytonSuperior.com and you can access all of those technical and safety data sheets. So let's talk about who is Dayton Superior. We're not just about accessories and chemicals and forming. We're about the whole thing, a bundled approach of what you need. We are the leading provider of engineered solutions, and we're doing that for the concrete construction industry. We do specialize in the products that I had mentioned: Simon's forming shoring, concrete repair and restoration, bridge deck, rebar splicing, precast and tilt-up. We've got all of the solutions that you need for your project for the concrete construction industry. We've got chemical solutions that are specifically formulated to meet those design specifications in both new construction as well as your retrofit or repair needs. Along with the largest, most experienced engineering, we have a big sales team in the industry that offers world-class customer service and care. And we give you 24-hour ordering and status account information as well through our e-commerce sites. So in today's topic, we're going to be discussing strand restraining devices. That's hold downs and push downs. And with us today is Chuck Hoke. So Chuck has been in the construction industry for over 49 years, 20 of those as a dealer for accessories, forming, and chemical products. He knows the ins and outs of all there is to do with construction for the concrete industry. 29 of those years have been with Dayton Superior. So Chuck has worked both as a product manager as well as numerous other different types of positions that lead him to his breadth of knowledge. He has a business and civil engineering degree, helps contribute to his role here at Dayton Superior as our subject matter expert. Currently, he is in the training role as our national training manager, and very integral in helping out customers and internals understand so much about our product portfolios. So with that, I'm going to let Chuck talk about strand restraining devices.
All right, well, thank you, Heidi. And good afternoon, everyone. Today we're going to talk about strand restraining devices, more commonly known as hold downs and push downs. We are going to be looking at hold downs first. Typically, a standard hold down is just that. It holds the pre-stressing cables in position so that you can drape your cable throughout your precast segment. This enables you that when you tighten up, put the stresses on it and everything, you can actually compress that concrete and get a stronger precast unit developed by use of the pre-stressed strands. The strand devices that we make, and typically we are one of a handful of suppliers for this product. Typically this product here needs to have a swivel action because it is going to typically be where cable is going to come from an upper position in the strand, in the precast segment, down to a lower segment and then go off or run down through the segment and then obviously change direction again because it's part of the draping of the pre-stressed strand. And with that being said, this is typically what you're looking at. You've got various loads here that you have to calculate out here. And typically, to calculate the uplift load calculations, the H, which is the horizontal load on the strand, and the V, which is the deflection, obviously, of the strand being from the top side to the bottom side of it, and H also being used as the distance between the hold downs from where they're actually positioned. So typically, all those figures, the horizontal load in the strand, typically H is typically what is being pulled out by the chucks. The PU is the vertical uplift, and the GU is the vertical hold down part of it. So typically, if you have a hold down, you're actually going to have the same hold down doing a hold down and a hold, what I'll call a hold up, which would be the PU position. The hold down, for every action, you basically have to have an equal and opposite reaction. So as I said earlier, for every pickup pressure being pulled up, you have to have a hold down pushing down in the GU condition. So let's do an example of how we would actually calculate what load restraining devices that you would actually need, or hold down that you would actually have to do. So you have a total lift of 28,900 pounds going on the strand itself. Vertical differentiation between heights is 3 foot. You're going to have a distance of approximately 30 feet between hold downs and hold ups. So a pull up is going to have to be 28, take that 28,000 times the V, which is 3 foot, divided by the height of it. So that is going to give you a figure of 2,890 pounds per strand. So you're going to actually have to have a hold-up device that is actually going to have to withstand 2,890 pounds per strand. Now, typically there are multiple strands in every precast segment here that's actually being pre-stressed. There can be a multitude of strands, anywhere from 4 or 8 to 20 to, I've seen as many as like 35 to 36 in a precast segment, a precast beam. So we are talking. We are going to, as we said, we had 28,900 pounds per hold down. Well, we have to have the same thing in a hold up situation. So this being a 6-strand pattern, we would typically have to have a 28,900 per strand times 6,000, or a grand total of 17,340 pounds. That is the total hold down figure that we would have to have. You always add 5% for friction. That friction is where the strand typically will run through the rollers, etc. It's kind of like a little safety factor involved in it. So basically, we're going to be talking roughly, we need a hold down that will actually hold up 18,270 pounds, and it will be a 6-strand hold down. To determine the hold down, we check the load per strand and then the load per hold down. So we've accomplished those 2 segments so far with the last couple of slides. Now, the hold downs are a little bit unique because they are always made to order. We do not make any of these ahead of time. So typically, if you are looking at having a hold down made for you, you're looking for a hold down, anticipate you're going to have some assembly time required, because every hold down is unique and individual. Typically, they're made up by a multitude of various parts here, from lock nuts to bushings to side frames to spacers. You have a long hex head, grade 8 hex head cap screw. You have obviously rollers involved in it that actually the strand will actually pass through, under, and over on top of. They're going to be, sometimes you have to have a restrainer plate put in place, and this actually helps the strand stay in alignment where it can't pop off to hold up. Sometimes precasters don't care for that restrainer, so some may have it, some may not. And we also have all these get put together with a restraining clip. And down at the bottom, we have a swivel lug that will actually accommodate a coil bolt or a piece of coil rod that would be anchored to the bottom of the form or to the top of the form, depending on whether you're using it as a hold down or hold up. This is a very standard 3x4 hold down pattern. And like I said, the patterns will vary. Typically what they're going to do is you're going to see a 3x4, then here is a 2x4, and here, strand is going to actually vary how they actually are going to hold the, here is a 1 strand where they actually have all the strands put together in a single line running down here. Sometimes they'll actually have 2 strands running on the same rollers. Depending on what pattern they want to use or how they're going to actually have it configured, Dayton Superior has a multitude of different arrays as to how they can actually be made. And like I said, each one is made to order. So when we get the requests here, we typically have some standard ones that are in place here. We have the H21 through H56S strand restraining devices. Here is just some typical strength requirements from our handbook. This chart is online, available for you to look at. You can see what strands we have, strand restraining devices we have, and by this you can actually determine what size inside rod you have to hold it down or hold it up, depending. You will also have here strand restraining devices. Here should be stressed in descending order from the top down. So typically you're going to start loading the top and then running all the way down through all of the strands. Typically you're going to run here, a lot of times you will start at the center, especially if it's an odd number of strands. You're going to start loading in the center and then work your way out and then in and then out. So you always want to start in the center of each row and work your way left to right. Because there is such a wide strand restraining devices, it should be stressed by loading the center row only. And sometimes you will see that comes through. Guys will want to load the center, but what happens if you only have 2 strand rows? Typically, you're always going to start, I like to start on the left and go to the right, left to right, all the way down through, from top down. You don't want to go top down all the way on one side, because what happens is you will overload that side and it will want to tilt. What we're trying to do is when we load this, to load it uniform so we stay in line. For safety, all single row strands should be stressed from loading the strands from the top down. Obviously, if there's a single strand, just start at the top, work your way down. We've made this pretty simple. We actually have a hold down order form, which can be cheap. You can basically get this online on our website, DaytonSuperior.com, or contact your local precast representative for Dayton Superior, and they can actually forward it over to you. The strand restraining device, also used as a hold-up, typically is designed for a single use. It is not designed, when you're using it as a whole pushing strands down, it's usually going to be embedded in the concrete. A lot of times when it is used outside of the concrete, it's going to be up on top. We do not recommend it being used a second time around. So basically, it's only a one-time use, then discard. Reuse can result in fatigue. A lot of times, anytime you have a steel product, whether it be a tie, a taper tie, a coil rod, anything, and you actually stress the product over 70% of the ultimate load capacity of it, you typically are putting that product in fatigue mode, and you don't know what the safe working load is after that. So that's why we only recommend that all restraining devices only be used once, whether it's a hold down or a hold up. If it's one, you do it one and done. Hold ups, typically the load at the points where the loads will be held up to basically applied for the hold up, basically it's for holding the strand up in the position so that you know when you drape these strands, and these are going to, a lot of times they'll end up being tied off here once it's held up with a chuck into place to actually tie it off afterwards.
So a chuck into place, not you.
A chuck in place, yes.
Okay, a chuck in place, okay.
It goes through to hold these strands, so you're actually compressing that concrete component, a concrete unit. And like we said, concrete is very strong in compression, not very weak, but it is not very strong in tension. So when you're doing a beam, you're putting it in tension across that beam. If where you can compress that concrete, you're actually increasing the overall capacity of that structure. Hold downs. Excuse me. I mean, we finished talking about hold downs, so let me talk about push downs. Push downs is similar to a hold down. It's in a lot of precasters actually prefer using these because it's a very easy and quick and simple way to actually hold down or push down a strand, especially outside of the concrete itself. Concrete typically has a special bolt that actually is connected. It is threaded on the top side. It is tapered down through, and the push down comes down and just basically straddles over the top of the strand. The strand then, once you're done pouring your concrete and you got everything stressed, you will then release this by taking the nut off the top of the bolt that's in use here, and then it will pop right out because of the taper on it. The little clip, the restraining device, will actually stay in the concrete. It is actually just held in place there with a little, almost like a push pin type setup that would actually anchor that on top of the strand. Here you can see we have three different push downs. We have a number 3, which goes 1 to 3 strand, 4 to 5, which does 4 to 5 strand, and then a number 8, which does 6 to 8 strands. And these are commonly used. Probably one of the more common ones that we have is the number 5, which is a 4 to 5 strand, primarily because it enables people to actually push down with a single unit. And this is the only component that they're losing, and this piece is, this a push down here is much less expensive than a hold down. So with all that being said, all of this data that we've mentioned here and calculations, et cetera, all available online through any of our technical data sheets, product pages, engineering services, and the order forms are all available on DaytonSuperior.com. Also, what you'll find on Dayton Superior, we made mention to get a hold of your precast technical sales rep. All that information is listed on our map section. We'll tell you from where you're located, who your sales rep is, who your technical sales rep is, and who your precast sales rep is. Also on here is also a listing of all of our distribution centers, totally available. One of the other things that you're going to actually see on our website is, and this is something new, is a direct link to our Training Tuesdays. And you can email Heidi or myself at training@DaytonSuperior.com. And then you can follow through with the email, and then that'll come out to either Heidi or myself. There's always one of us usually looking at these emails on a daily basis, so as soon as it comes in, we will get a reply off to you. If you want to get started for your training requests or anything, feel free to scan in with your phone on the QR code over here on the right-hand side of the page. That will actually take you right into a form on our website that will actually bring up a request for any in-house training that you are looking for, or online training, should it be, that can be done, relatively quickly. In-house, usually it takes a little bit longer to set up, but we can accommodate anybody's needs or wants on that end of it. And with that being said, I'm going to say thank you. And right now, if there's any questions, please go back to the top of the page here where you have your chat functionality in the Zoom call. And you can either chat in to fill in a question in there, and we will respond. If we end this presentation early and don't have a reply for you while you're still on, we will email it all over to you with a response.
Yeah. Thank you, Chuck, so much. I learned quite a bit. So while you're putting your questions in, just wanted to reiterate, with the hold downs, we talked about the resources and the handbooks. We customized to fit your needs. Like Chuck said, it is all customized for the type and the load that you need. Just keep that lead time in mind. And that order form is simple and easy to fill out, and your customer service or sales representative can assist with that. Okay, so just want to thank you for coming. Remember, these are recorded. We have them all out there. This should be like the 57th, I think. That's a pretty big deal. So out on Training Tuesday, there is a direct link with all of them and the ability to see accessories, precast, chemicals, all that good stuff. We do one of these each week with different topics and various product experts, so that's exciting. And it looks like we don't have any questions. So with that, we'll end our presentation, and thank you for joining. And until next time, we'll see you next Tuesday.
Thank you, everybody. Have a good day.